questions that we want to see you do, go over, have questions about. Seeing a lot of 1s and 2s, and then there was some random. So everyone put up either 3, 4, or 5. 5 or more. So 1 and 2 and 5. And your translating problem can't be done in Desmos, so you have to know how to translate it. So the product of a number and 4, so those two things are being multiplied together, divided by 3. So pick a variable, multiply it by 4, and divide it all by 3. Questions on that one? For the line of best fit, if I added in a table and put those points in, then I could type in my y1, the screaming line of tilde, mx1 plus b. And we would get y equals negative 1.5x or y equals negative 1.5x plus c. Either one. Questions on either of those? Okay, and then number 5. This one I could double check it in Desmos. And I know it's going to be a solid line, shaded below, starting at 1 with a slope of 2. So on your graph, it would look something like this. Something like that. Questions on that? Right. Today we're going to talk about the last thing for Unit 10. So everything we've talked about from Unit 9 to Unit 10, this is all what's going to be tested on the SWL, on the test after the SWL. Today we're talking about curve of best fit. As we start doing this, you'll see a lot of these steps are the same as line of best fit. We're just finding different things today. So all of the steps are, again, on your notes if you get lost at any point. We're going to do it in the calculator first, and then in Desmos, and then, again, for exponential. Thanks for watching. So go ahead and reset your calculator first. Second plus 712. And then we're going to go into stat, edit, enter, 1 or enter, and then put in that table of values on the front page. And then once you have all of your data in the table, just like for our line of best fit, we're going to go back to stat, scroll over to calculate, but instead of doing number 4, we are now looking for a quadratic regression, which is going to be number 5. And then just like before, since we are looking for different y values for predictions, we're going to store it. So go down to store regression equation, hit alpha trace, and then enter 3 times. So this would be our quadratic equation for a best fit. That was, we won't have a b term, but this would be y equals negative x squared plus 7. And then we're going to use that equation to predict y values for 2 different x values, when x is 3, when x is 4. So you do this one of 2 different ways. One, go into the table, second graph. There we go. And then look at your 2 different x values and write those down. That would probably be the easiest. Or you could go in and store one of your values as x. You have to do this separately. So if I go back to my home screen, I type in 3 STO x, hit enter, and then type in alpha trace and hit enter. Either way, you just need to figure out one of those ways. So the y value when x was 3 was negative 2. What about for 4? What was that y value? Should have been negative 9.
Can I go back and
On there, like the number 3 or like?
It's the number 3 for x, yes.
I thought it was like
wait, so like how did you find negative 2 on the calculator?
You could go to the table, or you could do the store method. But the table only works if you stored it in step 2. Same thing with the store method.
So as long as you do this part by storing it, then you can go into the table and find those values, or store it as x. You find it. Okay. So now we're going to do the same thing in Desmos. The steps are very similar to a line of best fit. We're going to use the same table, so that table's on the back of this. In your iPad, if you don't have your iPad, add in your table and start putting in your points. And really, without zooming in, I see that it's making that U shape, that parabola for a quadratic. And then just like our line of best fit, the equation, the regression equation in Desmos is very similar to this quadratic equation in general. It is on your notes, so we're going to type this in using your x1 and y1 again. y1, the squiggly line, the tilde. But then you're going to type in ax1 squared in that order. And then plus bx1. And then plus c. And I can see that this line, this curve of best fits this data because it goes through all the points. And it gives us that same equation. Do we have any questions on, let me do this. If you were finding the if you were finding the y value for those given x values, you just type in those numbers and see where those two lines cross. Do we have any questions on how the calculator or the Desmos regression works or curve of best fit works?
Can we use Desmos on our test after this?
For this section only. Alright. Now on the next page we're going to do the same thing but with our exponential regression. So I'm going to start with the calculator. If you want to use Desmos and try it in Desmos first, the steps are also there, but I am going to show you in the calculator. I'm going to go back to stat, go back to edit, and I'm going to clear out these numbers by going to the top and hit clear, not delete. And then I'm going to go ahead and type in these values. You can type them in as fractions using your alpha y equals, or you can use decimals, it doesn't matter. Go to the top, hit clear.
In this, we know already that it's going to be exponential, but what's that pattern in our lives? What's happening each time?
Multiplied by 2. As we do some examples later, recognizing the patterns are going to help you figure out which one this is. So then in the calculator, same steps, go back to stat, go over to calculate, but then you're going to go all the way down to 0. That's your exponential progression. And then same steps. Hit enter, go down to store, hit alpha trace, enter 3 times. So our equation for this would be y equals 1 times 2 to the x, or just y equals 2 to the x. I'll have to turn this off and restart it, but for now I'll just write it. This is your curve of best fit for your exponential. And then I wanted you to find the prediction values for an x value of 3, -3, 4, and -1. So we'll do 2 of these in the calculator, then 2 of them in Desmos. For 3 and -3 in the calculator, I could again go into my table. That would be the easiest, so we'll just stay there. What would your y value when x is 3 be? And then what about when x is -3?
0.125.
It's, say that again.
0.125.
0.125, or as a fraction, that would be 1 e. Okay. Type these same numbers into Desmos. Since you have your table already, you can just use those values and change your y values. and that one got loosened up. I can see that it's making that curve. So then in Desmos, for our regression equation, I'm going to type in, using my y1 and x1, y1 tilde a b raised to the x1. So really, it's just your exponential equation again, but using x1 and y1 in the tilde. So that equation again would be this. To find 4 and negative 4, you could type in x equals 4 and x equals negative 4. Find where those 2 points cross. You may have to zoom out. What would the y value when x is 4 be? And then what about negative 4?
0.0630.
So 0.06 or 160. Do you have any questions about how to put this into the calculator or in Desmos?
How did you put that?
Just put in alphabet codes. Those are not in the data. I just did alphabet codes. So it may not work. Mine is a computer, but the decimal will work just fine. Negative 1, 1. Just cross out the negatives. So we're going to plot all of these points, determine what type of graph it is, and then find the equation of curve of best fit, not for the linear one, but for the other two. So go ahead and start plotting all of those points from 1 through 3. And draw the curves lines through them. Alright, for number 1, what would that function type be? Linear, quadratic, or exponential?
Oh, linear.
The line is linear. So we're not going to find that function. You could if you wanted just to practice, but we're not going to do that together. What about the second one?
Quadratic.
Quadratic. So we're going to find that equation here in a moment. And then the last one. Exponential. So I'm going to have you 3 tables find the quadratic curve of best fit, and you 3 tables find the exponential curve of best fit. Find that equation and tell me what that's. Repeat more.
Y equals 2 to the power of x.
Okay. And then we just need our quadratic.
In power minus 1.
Minus 1.
Yes.
And that will be all graph.
I have a fish.
Because I think there's something missing there.
Yeah.
X squared plus 2x minus 1.
Yeah.
Yeah. Questions on either?
Wait,
Yes.
the quadratic, is it always going to start with x squared?
It's gonna be y equals first, but then it depends because if depending on the function, you may have a number in front of x. Okay, we're not gonna do 4 through 9, but there's a couple that need fixed. 4 through 6 is good. 7 and 9 have typos. Change this first one to -1, 8, and this last one to 4, -9. And then we're going to actually look at number 10. So in number 10, we see a coin is thrown off the top of the Statue of Liberty, which is 305 feet from the ground. The height h of the coin is recorded after each second t in the table below. Go ahead and put this into either Desmos or your calculator. And which function do we think this might be? Quadratic or exponential?
Quadratic.
Yes. For a couple different reasons. Because we see it starting to make that curve shape. It's going up and coming back down. Exponentials don't do both. But also in the context of the problem, if I'm standing on the top of the Statue of Liberty and I toss a coin off of it, 1, that's dangerous, so don't ever do that. But 2, it's going to come up and then gravity is going to make it fall back down. So quadratic would be your best bet. Now I'm going to show you what happens with both equations. So with our quadratic, it looks like it goes through all the points. It matches it perfectly. My exponential, I have to zoom out to see the curve, but it doesn't really fit it well. One other way you could decide is by looking at the correlation coefficient, the R-squared value, and I'll show that in the calculator in a second. For the quadratic, I see that my correlation is 1. That means it's really strong. It fits most of these points. It fits all of the points if it's 1. The strongest is 1. But in my exponential function, it's not very strong at all. It's not fitting a good portion of the points. So go with whichever is strongest. In the calculator, if you wanted to find that, if you go into mode, there's something that says stat diagnostics. If you turn that on, and then when you do your stat stuff, I don't remember which one is in here. So I'll do my exponential of whatever I just had in here. You'll also see that R-squared value. Now this one says 1, but that was a different function. That was the first one we tried in the calculator in this one. But you could use that to help you determine also. So we said exponential. What was that? It was quadratic, my bad. What was that equation?
Got it. 1 equals -16x squared plus 78x plus 305.
Is that what you got, sorry? Yes, good. So then we're going to find the height of the coin after 7 seconds. So type in x equals 7 in another line and find where your quadratic or your parabola and that line cross. If you're doing it in your calculator, if you had this stored, then you can go to the table and find when x is 7.
Second and back.
It is 67. So we go back, just to show that. If I zoom out a little bit, and then I click on those two, it would cross at 67, which makes sense because the coin eventually has to get closer and closer to the ground, so it couldn't still be in the 300s. That would make sense because of gravity and velocity and all those things.
It'll get like negative 200 feet after enough seconds.
Yes, and that also wouldn't make sense because realistically, you can't go to the ground.
That would be strong if there's enough force.
Possibly, if a superhero threw it, maybe.
Okay, so 67 feet.
Yes,
How'd you find it? Like
on the calculator. So I have to put these back in first. So this will be- If we go into stat, and we know it's quadratic already, so quadratic regression, I store this after trace, enter 3 times. I get the same thing, I see my R squared value is 1, but then I can either store the value as x, so 7 STO x, and hit alpha trace, and enter, or you can go to the table. And label, not the graph.
But like, how do I find that one?
It's just it does. That's the plus. And then zoom. And then see what it does. Your equation. Yes. Zoom out. Any other questions on that one? We're going to do one more, and then you're going to have time to do some SOL practice, and then I will say at some point that you could work on those math after a certain point in time. But going on to number 11. In number 11, the data shows the number of book club members for 4 consecutive years. Determine which model best represents the data. Go ahead and put that in.
When we put get the chart thing in,
We're in the calculator, stat, edit. Which one do we think this might be?
third way.
Quadratic or exponential?
Oh,
Exponential. Now I'm going to show you both of these because this would be an example where you might think it's the other. So if I did the quadratic first, this goes through a lot of those points. But theoretically, realistically, if I am looking at number of book club members, they usually grow. Sometimes they drop, but not usually by a whole lot, so it shouldn't go back down. So it wouldn't be quadratic. Also, when I look at the correlation coefficients, the R squared, the quadratic is really close, but the exponential is 1. So I know that has to be the one that fits. And also, realistically, book clubs don't grow exponentially like this unless, but it depends on the book, author, genre. But usually, they don't grow this big to this side. So that equation would be y equals 5 times 2 to the x. How many members would there be in 8 years?
1,280.
Yes. Again, usually this is not going to happen, but in this theoretical math case, sure. Do we have any questions on how to find curve of best fit for quadratics or exponential functions? Okay. So I'm going to say for the next 20-ish minutes, everyone's going to get a new SOL packet. This would be similar to how the SOL questions would be styled. The JLab questions are also similar. I want you to try and do as many of these as possible in the next 20 minutes. You guys can work together, use Desmos, use your notes, use your calculators, ask me questions. This is the time to remember how to do things. How do I do this in Desmos? How do I do this in a calculator? All those things. And then starting next week, I'll be checking these weekly like I did for the other ones, but Monday will just be 1 through 7. So at the very least, get 1 through 7 done today. Questions on what we're doing for the next 20 minutes?